In this video, we will cover what is the difference between reasoning model and a generic model or non-reasoning model. So let's first understand this term, what is exactly reasoning. So reasoning is basically a process of answering questions that require complex multi-step generation with intermediate steps. Now, for example, if I ask you what is the capital of India, this is going to be a non-reasoning question because we don't have to perform multi-step thinking to get the answer of it. Whereas if you look at this question where we are saying if a train is moving at 60 mph and travels for 3 hours, how far does it go? So in this particular question, you have to perform some thinking, you have to perform some intermediate steps to come up with an answer. So that's why this particular question is going to be considered as a reasoning questions, and this particular question is going to be considered as a non-reasoning question. Now, if we run it through generic LLM or a non-reasoning model, and if we run it through reasoning LLM, then the responses would be a bit different because this is a normal question. So modern days non-reasoning LLM would also be able to answer this question, but they can come up with a plain response. Whereas if we run it through a reasoning LLM, then it will perform multi-step thinking. It will try to understand what we are asking. So the response from reasoning LLM would contain thinking, and then you are going to get a response. Now this reasoning thinking can be displayed in two ways. One where it is going to be explicitly included in the response, and this is going to be visible to a user, and that's how DeepSeek reasoning model works. So whenever we are asking question, it will give you the thinking token as well and along with the response, so any user can see that. Whereas commercial models like OpenAI reasoning models, they would run the thinking or multiple iteration, but they would run as an intermediate steps, and that is not going to be visible to a user. So you can still get a response where a model is thinking, but those thinking is not going to be displayed to you. Now, as mentioned earlier, for this particular simple question, it's not like generic LLM cannot respond to this question, but the way it respond would be different from reasoning LLM model. In some cases, if you want a thinking response, then we can also try to think step by step in a prompt to generic LLM just to mimic how thinking model works, but this is still not going to be 100% in sync with how reasoning model thinks and work. But by prompting this for simple questions, it may give you some thinking steps. Now, the next question would be when to use reasoning models. So we can use reasoning models where we have to deal with complex tasks such as solving puzzles, advanced math problems, or challenging code tasks. Whereas for simple tasks like summarization, translation, and knowledge-based sharing, it is not recommended to use reasoning models. You can still pass it and it will able to give you a response. But for this normal cases, if you are using a reasoning model, then the cost would be a bit higher if we compare it with the generic or non-reasoning models. Now, this is a short summary of comparison. What is the difference between reasoning and general purpose LLM or a generic LLM? So you can see the primary purpose and strength, that is going to be your first point. So here it says explicit step-by-step problem solving and logical reasoning as we discussed, and here in this case general purpose text generation and understanding. After this, what would be the problem solving approach? So it breaks down the problem into smaller sub-step and shows intermediate reasoning, which we call thinking. Show the output directly without showing intermediate step, mostly pattern based next token prediction. Output is structured, highly structured with clear delineation between reasoning steps. General purpose LLM is going to be more flexible and conversational, may mix reasoning with other content. Now let's talk about the training, specifically trained on step-by-step reasoning task and formal logic, whereas generic LLM trained on diverse corpus of text data with many different reasoning style and purposes. Usage of chain of thought built into the core architecture and training process, whereas can use chain of thought prompting but not inherently designed for it. Must specifically ask for this in the prompt, as we covered earlier. Interpretability and error detection, detecting errors is easier due to explicit reasoning steps, whereas black box nature makes reasoning for output harder to trace. Now the computational efficiency may require more computing resources due to step-by-step processing, especially at inference time. Relatively lower computing requirement at inference time and usually more efficient for direct responses. Now latency for response may be slower for simple tasks that don't require explicit reasoning, and for generic LLM may struggle with complex logical problem LLM requiring step-by-step analysis and interpretation. Now, there are some examples like OpenAI O1, O1 Mini, O3 Mini, DeepSeek R1, and for generic LLM, we have GPT-4o, Llama 3.3, Claude, and other models. Now, the use cases: scientific reasoning, legal analysis, complex problem solving, AI agents with multi-step decision making. Whereas for generic LLM, we do have use cases for chatbot, text summarization, content generation, Q&A, and code completion. Now, this is from a theory perspective. Let's try to enable it in the code and cover different scenarios what we have discussed so far. So I'm going to go to my Visual Studio, and here I have written a very simple code. If you are covering our playlist, then you already know how to enable OpenAI and how to pass messages and get a response out of it. We can take a very simple code, and I'm going to ask same question what we have seen in our diagram. If a train is moving at 60 mph and travels for 3 hours, how far does it go? And here I'm using GPT-4o, and it's a generic LLM, and we'll see the response what we get. And we know this is a very simple question, so any modern LLM would be able to solve it. It's just that we are going to focus on the response and see like how the output is being generated. So let me just go ahead and run this code. So here you could see the answer, but by default it has come up with some kind of reasoning. Though it's a generic LLM, but you still try to come up with the formula and then try to put the values in the formula to get the out. So as we have seen, we can also enable some kind of thinking in generic LLM by passing think step by step. So here I would just say think step by step before giving final response, and I would just go ahead and run this. Now you could see we are still getting 180 miles over here, but now if you see the output, it's a bit different what we have got over here, where we haven't asked it to think step by step. But in this case, if you see where we have asked is to think step by step. So first of all, it is writing this formula, then it is just trying to identifying, okay, what is the speed and time. Now it's calculating the distance by going over it step by step. So there is a identify the formula, substitute the known value at step 2, and then perform the multiplication. Now let's try to run it against a reasoning model. So I can just go ahead and try to run it with O1 Mini, and this is going to be OpenAI reasoning model. So as we have seen in our diagram, because we are using OpenAI, so it's not going to show us a thinking token. It is still going to perform some intermediate steps. It will perform some reasoning, but that is not going to be visible to us. And one more thing what we have to do, we don't have to pass it like think step by step, because this is a reasoning models. It will perform this one automatically because chain of thought is inbuilt into their architecture. I will just go ahead and run this code now. Now you could see it has automatically come up with this given criteria and then the formula, and it has calculated the distance, and at the last it is giving answer without specifically asking it to think step by step. But one thing is still missing. This is a reasoning model, but we cannot see its thinking token. But we can see the thinking token if you are using any open source models. I'm going to just change it to an open source thinking model, which is going to be DeepSeek R1. And I'm just going to use it via Groq. I'm going to change this to Groq. Here, I'm just going to say from Groq, import Groq. And I have already installed it. If you don't have it, then you can install it using this command. Now we do have a Groq, and this is pretty much compatible with OpenAI API. So we don't have to change anything much over here. We just have to change the model. And in this case, I am going to use this model, which is mentioned on the Groq Cloud platform. So I'm just going to take this model and then put it over here. And now if I go ahead and run this code, then you can see like we were able to get the output, and it is going to get started with think tag. And here you could see, okay, what this model is specifically thinking. So first it's saying, okay, first I identify the two given values. The train speed is 60 miles per hour and the time it travels is 3 hours. Next, I recall the formula for calculating the distance, which is speed multiplied by time. Then I plug the given values into the formula 60 mph multiplied by 3 hours. Finally, I perform the multiplication to find the distance traveled. So here its thinking has been completed. After this, it is just taking all these values and then trying to put it into the formula. Here also you can see the given speed time, and then it's just plugging the values in the formula to get the final value. If you want to pass more challenging tasks, then you can just try to pass some logical puzzle, and then you can clearly see the responses what you get from generic LLM and what you get from reasoning LLM. You can pass some puzzles like this, and in this case you could see when you are going to get a response from all these reasoning models, then you could see their chain of thought, how deeply they are thinking about it, and then like before generating a response, which won't be a case with generic LLM models. So in this particular article, there are few examples which you can pass on and get the response out of your model. So this is a puzzle, and then there are some codes. All this you can try it on. I will put this link in the description. But yeah, that's all what we have in this video. Thank you for watching.